This is a word problem involving rational expressions. It says, Cyrus was pedaling a pedal boat down a river with a constant current. Cyrus can pedal 7.5 kilometers per hour in still water. Cyrus pedaled 3,600 meters upriver against the current and 3,600 meters back downriver with the current helping him. Cyrus made the total trip in 1 hour. How fast was the current? Okay, well, we approach this question by first trying to determine what the relevant quantities are. In this case, we underline 7.5 kilometers per hour, so obviously speed is relevant. 3,600 meters, obviously distance is relevant. And 1 hour, obviously time is relevant. And so we want to determine what is the relationship between speed, distance, and time. Now this next sheet, sometimes people don't like to see this next sheet because they think it cheapens the solution a bit. I actually find it quite convenient to see this laid out in a pyramid. I say that speed equals distance over time. For some reason that visual helps me. If it helps you, that's fine. Therefore I also know that time is distance over speed and distance is speed times time. Again, we can obviously, once we know speed is distance over time, we can use elementary algebra to get back to time equaling distance over speed and also distance equaling speed times time. But I do put it this way because I think the visual is very helpful for me and sometimes for other people as well. Now, in this particular question, we have two scenarios. One of the scenarios is when Cyrus is pedaling there. He's pedaling upriver. The second scenario is when Cyrus is pedaling back. He's pedaling downriver. And now we have to put all of this into some sort of a coherent whole. So we ask ourselves ultimately, what is this question looking for? Ultimately, the question is asking how fast the current was. So I'm going to let that be x. X is the speed of the current. And I have to consider my two scenarios. One of them was there and one of them was back. My distance is measured in kilometers, my speed is measured in kilometers per hour, my time is measured in hours. And we want to make sure that all of our quantities are measured in those same units, and so we have to convert 3,600 meters in the question to 3.6 kilometers. The question says 3,600 meters, we make the conversion to 3.6 kilometers. The question says it's 3,600 meters there and 3,600 meters back. So in scenario 1, the distance is 3.6, and in scenario 2, the distance is 3.6. We know that the current of the river is x because we let that be in our let statement to begin our solution. So that means that when he's paddling against the current, he's going 7.5 minus x. And if you think about it, suppose he's pedaling 7.5 kilometers per hour and the current is coming against him at 3 kilometers an hour. He would only be going 4.5. In other words, you would subtract that 3. Well, we're using that logic. We're subtracting x, whatever that speed of that current might be. However, when he turns around and goes on the way back, he's got the current with him, so he's actually picking up speed. He's going 7.5 plus x. Now, unfortunately, we don't know how long it took him to get there, and we don't know how long it took him to get back. But we are going to be able to make an equation out of the time with respect to these two scenarios. We know that the time there plus the time back equals 1 hour. So we're able to now go back to our pyramid, and again, I find this visual quite helpful. We're able to go back to our pyramid and say, well, since time is equal to distance over speed, the time there must be equal to the distance there over the speed there. So the time there must be 3.6 over 7.5 minus x. And our units are taken care of because we made sure of that when we filled in the chart. Similarly, our time back is equal to our distance back over our speed back. So 3.6 over 7.5 plus x. And all of that equals 1. So we have this rational expressions equation, 3.6 over 7.5 minus x plus 3.6 over 7.5 plus x equals 1. Well, now in order to solve this for x, we know by now that we need to get a common denominator. Our lowest common denominator in this case will be 7.5 minus x times 7.5 plus x. And we also have to consider our restrictions. If we get to the end and our answer is x equaling 7.5 or negative 7.5, we'll know immediately that it's wrong because it can't be that time. It's a restriction in our original equation. However, rest assured it won't turn out that way in this particular question. So with our lowest common denominator in place, we can then restate our original equation in terms of that lowest common denominator. 3.6 over 7.5 minus x, multiply both numerator and denominator by 7.5 plus x. Plus 3.6 over 7.5 plus x, multiply both numerator and denominator by 7.5 minus x. Equals 1, which is the same as 1 over 1. So multiply both numerator and denominator by 7.5 minus x over 7.5 plus x. At this step, we can now, having stated our restrictions, multiply all three of those rational expressions by 7.5 minus x, 7.5 plus x. What that has the effect of doing is clearing out the denominators, and we can focus on the numerators. So sometimes I just write clear the denominators. What then happens is we have 3.6 times 7.5 plus x plus 3.6 times 7.5 minus x equaling 7.5 minus x, 7.5 plus x. In other words, once we got the denominators the same and stated our restrictions, we were able to ignore them. We then move to our next line where we expand things out and we set up a quadratic. Because we want to be a quadratic hero, we're going to let the right side equal 0. And we're going to get x squared minus 2.25 equals 0. It looks pretty complicated, but it actually simplifies to this. Now you might know at this point that the square root of 2.25 is 1.5, in which case you can do difference of squares right away. If you don't see that, then you can get rid of the decimal by multiplying both terms by 10. 10x squared minus 225 equals 0. Multiplying both terms by 100. So 100x squared minus 225 equals 0. We can then do a difference of squares on this. 10x minus 15 times 10x plus 15 equals 0. So 10x minus 15 equals 0, or 10x plus 15 equals 0. 10x equals 15, or 10x equals negative 15, which means x equals 1.5, or x equals, that should say, negative 1.5. Forgot to write that in. However, we know that the current on the way there is positive because, we know that the current is positive because the way we set it up, we set it up such that he was going to be going slower on the way there. So our current is positive, so x is 1.5. So we can say therefore x equals 1.5, and therefore the current flows at 1.5 kilometers per hour. And if we want, we can go back to our original formula and see if this makes sense. Well, if x is equal to 1.5, then on the way there he was going at a speed of 6. 3.6 divided by 6 is 0.6, so it took him 0.6 hours to get there. On the way back, he would have added 1.5 to his speed, so his speed would have been 9. 3.6 divided by 9 is 0.4, so it would have taken him 0.4 hours on the way back. 0.6 plus 0.4 equals 1.